I will now go over the discussion section. This section should describe how data relates back to your initial hypothesis and objectives, provide logical arguments explaining what your results mean, and how your data relates back to the hypothesis you laid out in the introduction section. Does your data support your hypothesis? If not, give an example of what might have resulted in your data, what could have been improved upon in this experiment if it were done again, and address any errors in protocol. So you should have an annotated example to help you and to guide you. This would be in the sample annotated paper in your Top Hat. However, here are a few additional instructions. The first paragraph of your discussion: 1. Reorient your reader back to the broader context of your study, so the OFT theory. 2. Summarizes the main results. 3. Connects results back to the hypothesis. So was the hypothesis supported? Was it not? And then 4. Address broader implications of the results. So here's an example paragraph where the first bit reorients your reader to the broader context. Then second bit summarizes the main results. Third bit connects back to the hypothesis. And the last bit at the end addresses broader implications of the results. So for the second and third paragraphs, you want comparisons to other peer-reviewed literature. So how do your results compare to other published studies? You'll need details. So what other studies did you find? How the results would compare? Why are your results similar or different? What makes your results similar or different? So as an example, at the bottom here, Smith and Brown, 2002, agrees with their findings that distance from tree influences foraging rate. Is not how you would do the results. Instead, refer to the green area. So for the next to last paragraph, you want to do your experimental caveats and future directions. So what extraneous variables might have interfered with or affected what your interpretation of your results, and how did these variables impact your results, and how were they ultimately influencing the outcome of your experiment. So here you should back up any problems with cited literature, and do not make this entire section about low sample size or where you did your experiment. So you can mention them, but don't make them entirely consume the question. So for extraneous variables, do not assume that if your hypothesis is not supported, you did something wrong. You could name a few things that you think might have gone wrong, but if your data is not supporting your hypothesis, it could just be that your hypothesis is not correct. There's a different answer of what could have happened. So don't ramble about things like things that affected your experiment or talk in excess of what you'd think you did wrong. Instead, talk about science and backed up literature that might support your data. So 5, what additional research needs to resolve contradictions or explain exceptions? So this is what's the next step of furthering this research subject. So the answer here is not to redo the same experiment in a broader area or adding more replicas. That's just a cop-out, really. Here we want some creative thinking about how your data differs from your hypothesis, or if it was the same, just what you think could better answer the questions of your hypothesis and the OFT theory. So 6, how do your results help us further understand animal foraging patterns? Why is it important to a broader audience? And 7 is what is the practical applications of your research? So how can humans use the information to manage species, habitats, etc.? So note the last question should be a paragraph or two, not a short answer. So question 7, so how could this information be useful? You want to be able to connect your research and why you're doing it to your readers and a broader audience. So what do we do now that the topic, what do we know about your topic that's important for research? Broader implications to a broader audience. So maybe it's agricultural connections, wildlife or habitat management, or maybe seed dispersal. Just come up with a few ideas of how this information could affect your readers. What do you talk about when your hypothesis is not supported and experimental design is not to blame? This is a time to think about other potential hypotheses. So an alternable credible hypothesis which explains your data. Whenever you cite literature for the entire your entire article, it should be at least 10 sources APA format, and be consistent on how you cite them. You'll likely need more than 10 overall, but minimum 10. Whenever you in-text citations, here's an example of how you would do that. It shows one author, two authors, or more than two authors. So one author, just the last name and the year. Two authors is last name and last name, year. Then more than two authors is last name et al. Period, and then the year. So no page numbers, and then be consistent throughout. What needs to be cited? So common knowledge does not need to be cited. So such as ants are ectotherms or ants are attracted to sugar, that does not need to be cited. But things that aren't common knowledge do need to be cited, such as optimal foraging theory. The definition of that's not common knowledge. It will need to be cited, ideally from the original source that came up with that theory, somewhere around the 1950s. So a note on citations. You'll notice that journal articles you read, how many sentences are cited in the introduction and discussion. So whenever you go through your 10 sources that you need, read through the introductions and the discussions, and you'll see just how many sources they have. On the paper I'm writing myself, I have about 50 sources right now. And use original sources. So if you find something that references a different article, find that original article. So here's a little comic. And here's a point breakdown on your rough draft, final draft, and etc. So this will be 110 points total, which is worth more than an exam grade. You'll have your initial rough draft, which will be completion only, and it'll be due at 2 p.m. on the day of your lab. You'll have your rubric assessments, so during lab, you'll sit down as a group and go through the rubric and make sure you all agree that it was fully completed. You'll have your final rough drafts, which is 35 points and due by 5:30 on lab day, so at the end of lab. And then you'll have your final draft, which is 65 points. Thank you.